Hello and welcome back to another little video. Today we're going to be looking at the proof of the product rule. So this rule states that given two differentiable functions f and g, the derivative of their product function, which is f times g, can be found using the rule. The derivative d dx of f of x times g of x is equal to the derivative of x times g plus f times the derivative of g. We can also write this as d dx of uv, where u and v are both functions in terms of x, is equal to u times the derivative of v plus v times the derivative of u. These are two ways of writing the exact same thing. Right, so to start things out, just like in the last video, we're going to start with the definition of the derivative. So we're going to find the derivative of f times g of x. Now, using the limit definition of the derivative, this is going to be equal to the limit as h goes to 0 of this function with an input of x plus h. So that would be f of x plus h times g of x plus h, right? So it's just that function, we replace x with x plus h, minus f of x plus h, minus fx times g of x, so the function without an input of x plus h, just with an input of x, divided by h. That's the definition. And as with every other proof that we've looked at so far, there is a little trick that we're going to introduce. And in this particular case, the trick is we're going to subtract and add. So we're going to take something away and put it back again to the numerator. We're going to subtract and add f of x plus h times g of x. And as you're going to see in a minute, this is just going to make everything work out nicely. So let's write out what we have so far. We're taking the derivative of f of x times g of x. And as we can see from above, this will be equal to the limit as h goes to 0 of f of x plus h times g of x plus h. And I'm just going to insert here in the middle what I've just spoken about here. I'm going to subtract off f of x plus h times g of x, and then I'm going to add that back straight away. So we're going to add back f of x plus h times g of x, and then we're just going to finish this up. We have minus f of x times g of x over h. Okay. So the reason that we have done this is because now that we have this massive fraction here, we can now split this fraction and write it as two different limits. So we can see that this is going to be equal to the limit as h goes to 0 of this first half of the fraction. So if we take the first two parts of this numerator, x plus h, g of x plus h, minus f of x plus h times g of x over h plus the limits as h goes to 0 of f of x plus h times g of x minus f of x times g of x over h. And the reason why I have done this is because we can then do a few more tricks. So what we might notice now that we're looking at these two fractions here is that for the first limit, we might notice that there is a common factor, and I might do it in blue. There's a common factor to both of the terms in the numerator of f of x plus h. So we can see it appears in both terms of the numerator there. So that's f of x plus h. There's f of x plus h right there. So what we can do is we can actually factor this guy out. So that's going to make this limit here. We can write it as the limit as h goes to 0 of f of x plus h. And I'll just write it outside of this, this fraction here. So f of x plus h times g of x plus h minus g of x over h. Okay, and for this second one here, the second limit, we can see that there is also a common factor. There's a common factor of g of x. So we can see there's a g of x there, there's a g of x there. So once again, we can take this out as a common factor. So we can see that this second limit is going to be equal to the limit as h goes to 0 of, and again, we're going to take out that g of x, put it out the front here, g of x times f of x plus h minus f of x over h. What can we do with this now? All right, well, let's see if we can simplify this. So h is going to 0, right? So for this first fraction, or this first limit, as h goes to 0 for the function f of x plus h, that's just going to become f of x plus 0. So that's just f of x. So we can just bring this outside of the limit. We could write this as f of x times the limit as h goes to 0 of g of x plus h minus g of x over h, yeah, plus the limit as h goes to 0 of, well, first up, again, this g of x here, that is not in terms of h. We can take this outside of the limit. So I'm going to write this outside here. As h goes to 0, g of x does not change. Yeah, because there's no h involved. Multiplied by the limit as h goes to 0, and then the rest of the stuff inside the limit. So as h goes to 0, of f of x plus h minus f of x divided by h. And what we might notice here is that by the definition of the derivative, this here, the limit as h goes to 0 of g of x plus h minus g of x over h, is by definition simply just the derivative of g of x. And this over here is actually just the derivative f dash x. So what we have ended up with is that this overall expression is simply equal to the function f of x times g dash x, the derivative of g with respect to x, plus g of x times the derivative of f of x. And that is just the product rule, which is exactly what we set out to prove. So we've proven that one, QED. Awesome. Thank you very much for joining me. I'll see you guys next time. Have a good one.